Thanks again. So today we continue with CVS and today's topic is slow response action potential. So let's move on. This type of response takes place in SA node, SA, AV node, and why so? These are the parts that spontaneously generate electrical impulse. When we saw about fast response action potential was that they required an external input to stimulate, whereas SA and AV node require no external input and fire spontaneously. So that's the reason why our heart, even without innervation, would keep on beating. Let's see the graph. This y-axis, let it define potential, and the x-axis, let this be for time. Here be minus 40 millivolt, here be minus 60 millivolt. So if we were to plot a graph, the graph would look somewhat like this. So this graph is divided into a few parts. This known as 4, this as 0, and this one as 3. So let's run deeper into each of them. 4 is again subdivided into two parts. Let this be A and this be B. Talking about 4, A. In A, sodium channels open. Sodium channels open. These sodium channels are known as funny sodium channels, also known as HCN. And if we see at B, which is beyond minus 50 millivolts, calcium channels open. And to be precise, these are T-type calcium channels. And when we look at 0, the graph still moves up, which signifies depolarization. In part 0, L-type calcium channels open. These further allow the entry of calcium ions into the cell, therefore further depolarizing the membrane. One thing to notice between slow and fast response is, in fast response there was opening of sodium channels for depolarization, whereas in slow it is taken care by both sodium as well as calcium. This influx of sodium is the reason that the pacemaker cells or the SA node and AV node of heart are autorhythmic, or they don't need any external stimulus to generate action potential. And when we see for part 3, in this, as always, there is efflux of potassium ions. These efflux of potassium ions leads the cell to again polarize and set back to its action potential, to its resting membrane potential. But one thing to notice here is, as in the previous graph, or in the graph of fast response action potential, we had a straight line between two elevations, which signified that there was an RMP or resting membrane potential. But in this one, if many such graphs are plotted one after the other, there is no straight line formed, or I mean to say that the subsequent or the next peak starts right from here. And as you can see, there is no flat line parallel to the time axis, which signifies there is no RMP here. Rather, there is a range which kind of works like RMP. And while reaching towards the end of phase 0, the T type calcium channels and also funny sodium channels tend to close. Therefore, depolarization stops, whereas the continuous efflux of potassium ions takes upper hand and therefore polarizes the cell again. When the potential reaches around minus 50 millivolts, oh, I forgot to mention the potential here would be around plus 30 millivolts. And when the potential again reaches to minus 50 millivolt, again the potassium channels start closing up. Therefore, again the potential of cell has reached at the previous region, which is between 40 and 60 millivolts. And so the presence of no RMP or a very unstable RMP or resting membrane potential, which lies between minus 60 and minus 40 millivolt, is the reason why pacemaker cells do not need any innervation to start or generate an action potential. I know it was a small topic, but thank you, and until next time, have a good day ahead.